This is sustainable materials. But before that, I would like to tell you something. That if you know the history of architecture before globalization or before the revolution of transportation, all the structures were built with local materials by native people with local technologies and adhering to the local climate, and that was more sustainable. But after the globalization, we started importing and exporting materials, and we started copying, the architectural style from West or from other countries. So that's where the sustainability was lost. So when you look at sustainable materials or energy efficient materials, you have to look at it from two aspects. One is manufacturing, and the other thing is the application of the material. Now, what is a green material, or what do you call, which material you call a sustainable material? Is that the material in which the embodied energy is very low, very less. Now, what is that embodied energy? Now, if you see, there are two things. One is manufacturing. In manufacturing, while manufacturing the material, the energy spent on that manufacturing process has to be low, and plus the energy consumed in the transportation of that material from a manufacturing unit to the site has to be low. So together, the energy consumed in manufacturing and the energy consumed in transportation, together it is called embodied energy, and that has to be low in a material so that it will be called a green or sustainable material. But that's why we used to call vernacular materials are more sustainable, because in vernacular material, the energy spent on transportation is very, very low. And some natural materials like wood, if the wood is planted exclusively for construction purpose as a building material, like they do in Indonesia or even in India now, we started doing that with bamboos, then it is sustainable, because if you see, the wood grows on two natural things, water and sunlight with photosynthesis process. So it doesn't require any energy, mechanical energy, what I mean to say. Whereas if you compare wood with other materials like aluminum or steel, it requires a lot of energy in the manufacturing process. So wood is, of course, the best sustainable material, but it's provided that it is grown up or it is planted exclusively for the purpose for construction as a building material, and if not from the jungle. If you cut jungles and use wood, then it may not be sustainable because you are causing deforestation. So it's very tricky when you call wood as sustainable material. Now, this was about manufacturing, but again, it all depends on how you apply the material. Sometimes that material in its basic properties may not be sustainable, green, but the way you apply it makes it green. Now, for example, see, India is basically a tropical country, right? So if you see, our buildings, that we require the shading devices, or we require to filter radiation of the sun, as it is very harsh in India. So even if our old buildings, you see the jalis, and we never used to have plain glasses like what you see today as glass buildings, because our climate doesn't allow us to do that. It is not suitable for our tropical climate. So these jalis now they are green features, but the material used for the jali may not be green in the manufacturing process, but because the way it is applied makes it green. Now that was the traditional old building. Now this is, I'm just giving you examples of our own projects. On the left side, what you see is a public building where we used aluminum louvers. Okay. Now, if you see aluminum, it requires a lot of energy in manufacturing, but the way it has been applied here as a sun shading device or to filter the radiation at the same time to allow breathing, that application makes it green material here. So it again depends on how to apply and what is the application of the material. That's what I have to say. Now, if you see, India is a very tricky thing to treat building envelope, because the wind also comes from the same direction from where the radiation is there. So you have to allow the wind, but restrict your radiation. So that's very tricky. But if you see the right side image, that's a bungalow where we used pine wood vertical louvers, or you can say fins. But then, as I said, that it's very tricky to apply such kind of things, because you cannot treat all the directions with the same treatment. Because if you think about west, you cannot use horizontal louvers or fins for the west side, because west side is very, very inclined. So you need to have vertical fins or louvers when you're treating the west. So again, the way you do it depends on which side you're treating. You know, again, the distance between two fins, or the depth of that, it is all calculated to allow good breeze, but not radiation. Now, see, maybe now this is the north side elevation of one of the buildings. Now you see, glass in its nature is not cannot be called as a green material, but if you manufacture glass with low solar gain coefficient, and if you use it for north, then it can be applied as a green material. Now that was about the materials. I will again explain you when I give you examples of my own projects. Let's talk about daylighting systems. I have always been saying that, you know, when you talk about green buildings, we all are behind, you know, getting these rating points, and we apply various materials, we apply various strategies. But if you apply the basic, you know, whatever is taught in architecture, basic principles of architecture to your building and to your planning while designing the first stage itself, then you can achieve a lot of sustainability. I'll tell you what it means. You know, that now see, this is the section of a building, say. So when you design fenestration, or when you design the building, the space, you have to remember that normally light travels only 7 to 8 meters from the edge of the surface of the facade, and then after that it will be dark if you don't treat with any skylights or something. So I normally, what I do normally is I allow only the floor plate to be not more than 7 to 8 meters in depth, and then there could be a corridor. But sometimes if you get an opportunity where there's no corridor and you can have light from both the sides, then your floor plate can be 14 to 16 meters. So in the basic planning itself, if you apply these things, there will be 100% light in each and every square inch of your space, and you wouldn't require artificial lighting throughout the day. So this is what some simple basic principles of architecture we have to follow. In case you are dealing with a larger project where you need to have wings, you need to have courtyards, you have to really work out such a way that, you know, that allows the dimension of the courtyards to allow proper light and ventilation to the spaces. So this is an example of one of the courtyard that we did in one of our project. This is again a public building, and the way this courtyard is worked out, it doesn't only serve the purpose of light and ventilation, but, you know, it also gives us additional waiting spaces, because in India, in public buildings, however you provide spaces for waiting, they're never enough because occupancy is invariable. So this is how we have to work on that. And if we see, even in the residential projects like a small bungalows, it would be ideal to have an open to sky courtyard. But with today in urban areas like Pune or Mumbai, it's not possible to have such a large space. But wherever it is possible, you can have such open to sky courtyards. They also work as they also work as a feature which gives you good light and allows us to have air circulation. And at the same time, they are the buffer spaces. These buffer spaces are very, very important in Indian climate, because, you know, and these buffer spaces have been used even in our traditional buildings. What is a buffer space? Is the space between interior and exterior, which allows it's just like those hospital spaces. Okay, where so these buffer spaces are very important in Indian climate, because they give us that insulation from exterior space to the interior space. So and again, you know, if we see in now with present scenario in urban areas like Pune or Mumbai, where it is absolutely not possible to have a big, large open to sky courtyard, where now the courtyard has been changed. It has been evolved in a different manner. Now we have a small courtyard which is very tall, like, because normally the residences are now G+2 or 3, and we cover it with glass. But it also works very well for the light and ventilation. You have, turbo ventilator in the courtyard, and it creates a stack effect, and your winds, wind is sucked in by windows, and there's a nice natural ventilation. You may not require air conditioning, mechanical air conditioning for this kind of spaces if you provide a right kind of courtyard in a residence. So I just see the section where all the spaces are there. There's a living, dining, and one side is family. And this courtyard is not just providing you a good light and ventilation, but it also helps you to have proper interaction amongst the spaces. So these are some of the examples which we have done this courtyard. There are two residential courtyards. One left side is just G+1. The right side one it goes very tall, G+2. But if you observe, there is a rotary ventilator, and it creates a nice air current, and with the stack effect, it gives very nice natural ventilation to the house. So every time it is not possible to have such a courtyard with the limitation of plot size in areas like Mumbai or Pune, where the land is very precious and one cannot afford. But you can still have some kind of slits, like it's not possible to have. Every time it is not possible to have a good size of courtyard in the urban areas like Mumbai or Pune, where the land is very precious, and you may not get enough plot to do this kind of planning. But at least one small slit in the skylight, one small skylight in the form of slit in the ceiling can help you a lot. Now look at this. We did this project in Solapur, where the living room has a skylight. Both these are skylights, and it gives a very soothing light. Or maybe sometimes in the side setback you can have such small courtyard. I can't call it a courtyard, but maybe a skylight. This is again a residence from Pune. Or maybe for your toilets, normally we have this kind of open to sky courtyards, so not exactly open to sky, but covered with glass. And this is the purpose of good lighting and without disturbing your privacy. Maybe again a small, if it is not possible to have a bigger one, we can have a smaller one, or we just might have a small, again, cut in the ceiling treated with a glass as a skylight, and it gives a very soothing light to the sanitary units. So this, after talking about all the strategies, I would like to give you examples of two of our projects which we did in Pune. These are public buildings. So the first project which I'm talking about is a circuit house in Pune. Well, I would like to just explain how we evolve our spaces right from the beginning, keeping in mind all the aspects of this natural lighting, daylighting, and green building ethos. So if you see this site, there's a proposed site there. If you see this proposed site, there is one structure, green. What you see as gray is a structure, and there are some trees right in front. Grown up trees right in front of the front margin, right in front of the proposed site. And then after leaving the space for the of the fire engine around the building, which is a mandatory setback, what you get is a footprint like this. So if you simply raise that footprint, now in this area, only ground plus 2 structures are allowed because it comes under defense area. So it is a very simple planning. We raise that block, and as I already talked about, that light doesn't travel more than 7 to 8 meters from the face of the building. We do not allow our floor plate to be more than that. So it automatically creates a central courtyard. And then we cut the west, because west normally has a very harsh sun, which is very difficult to treat with. So it is better, if possible, it is better to have not any functions to the west. So we simply cut it so that it also gives a good breeze to the courtyard. And then this is how the planning is done. There are 3 cores: main entry, VIP, and service entry, and the rooms to both sides. And the gray, what you see is the other areas like suites or cafeteria and all that. And they're connected by corridors. Now, if you see that yellow part, the corridors happen to be on south side. Because, this is what I call as buffer spaces. So corridors can be used to create those buffer spaces, which creates insulation between exterior and interior spaces. Then we added to the conference halls at different levels. And south side is again treated with louvers to avoid radiation from south. So after finishing, this is what the design is evolved as. These are just plans. I would skip through fast. I just wanted to show you the plans. There's a central courtyard and all the spaces are around that. And even the landscape in front is the extension of the central courtyard. This is the first floor. It also has a basement which accommodates about 120 cars. So another section. I was talking about creation of that courtyard, which you can see in this. So as I said, that west side, we hardly have any functions, but just one conference hall, which is treated with vertical louvers. Because west, the sun is inclined. So vertical louvers actually work very well for west side. So this is the front elevation you see, which is facing west. And then, of course, all other sides you have to treat as per the climate. Like north, we can afford to have glass to the north because north doesn't get any radiation of the sun, but ambient heat is there. So you have to be still careful about recommending the glass. You have to check its properties with low, capacity to restrict the radiation and all that. And what you see to the right side is the south side facade, which is treated with louvers, which we already talked about. And as I said that the courtyard, this is now repeated because this courtyard is from this building, which is worked out so well that it remains shaded throughout the year because people use it for additional sitting, waiting spaces. So there's two more views of the same courtyard where, there's also a water body, which acts as a microclimate modifier. Because then it's open from the west, so it brings the cool breeze and it brings the wind and it gets cool, and that can be it modifies the climate over there. So even though this building is VVIP circuit house, the entire building is not air conditioned. Only few parts of the building is air conditioned. I'm just showing you another view of that courtyard. Now, what were the passive strategies that we use in this building where like this, that the planning was done to suit the hard dry climate of the Pune. Then roof was treated with insulation. Then we use sharing devices according to the orientation to achieve thermal comfort. Then transitional spaces were created in the form of terraces and verandas, which also creates climatic buffer. And of course, all eco-friendly materials. This building actually is 5-star rated by GRIA as a green building. So we use all materials as green. Now, if you see the left side image, the recycled ceramic tiles are used. Ceramic tiles themselves cannot be green, but recycled ceramic tiles can be used as a green material because of the way it's applied or because of its application. Then we use AAC blocks, where the cement is reduced by fly ash. So we use a lot of such strategies. That is the front facade of the building. Another project I will quickly take you through. This is a collector office in Pune. Again, another public building, which is about 2 lakh square feet, about 200,000 square feet. So the challenge was that on the site, existing collector office was already functioning with in a different small buildings, and it was quite inconvenient for them to operate because the departments were segregated because of the nature of these buildings. They were all very old buildings. So they wanted to demolish this and have one single building where they can work under one roof. But the biggest challenge was that site had 197 huge grown-up trees, and again, saving trees is the first green consideration it should be. So after demolishing the small structures, this was the scenario. Now, if I had gone with the conventional design, because because this building is about 2 lakh square feet. It requires about 300 car parkings. A huge requirement of car parking is there. So by conventional planning, one would have gone for basement, and the floor plate was really going very high. And that was forcing us to cut about 120 trees, which was a menace to sustainability, which wouldn't have been allowed even in a place like Pune, because in Pune, if you have to cut more than 5 trees, the matter goes to High Court. And actually, it's a good thing. So the trees are saved here. So we thought of a different approach. We decided to go by a different approach. We identified empty pockets where the minimum number of trees were there. And then we created parking as a separate building to avoid basement, because basement was the main culprit for cutting the trees. And then we created 2 office wings and a parking wing separately. The parking wing was connected by bridges to these 2 wings. And again, as per our regular strategy, that floor plate should not be more than 7 to 8 meters. We created courtyards in these 2 wings. And then these 2 wings are connected to each other as well as to the parking building. And then we designed another wing on top of that, that is wing C, which again has a big skylight, or we may call it a courtyard, in the center. So by doing this, we saved 112 trees, and only 8 trees were shifted or replanted. So that was a big achievement. And then again, it followed all the green norms. The terraces were created. Then again, as the building faces west, we use vertical fence. This entire building was treated with vertical fence. See, this vertical fence is not a new material, but it has been used in our old buildings. But one has to now reinvent this, because in Indian climate, glass buildings is menace to sustainability. We can't afford to have glass buildings, which is simply, people are simply copying it from the Western buildings. Where in Europe or UK, glass buildings are okay because their climate allows them to do that. So this is how the evolution of the form is. Now this is the actual photograph of the building from top of that angle. These are just plans which I wanted to share with you. With this, how this courtyards are designed and spaces around that and the top floor. This building is only 10% of the building is mechanically air conditioned. Rest of the building is absolutely naturally ventilated, and it has 100% daylighting in each and every square inch of the building, of the space. Now this is a big plaza which we created by doing that, because in a government building, normally the waiting spaces, whatever you have the brief space, the waiting spaces are never enough. And in a project like collector office, where people come from all over the district, from many villages, and they spend sometimes their entire day in this campus. So we thought of creating spaces which were not in the brief, which were out of the brief, but which could allow people to have relax, to have their tiffins or whatever. So they can spend good time there. There is another view of the same plaza. That's the skylight I was talking about on top of that. Just sharing some view. This is the west side, so you can see the inclined sun from here. So this courtyards really help very well. I'm again repeating it because you can see the diagram here, that we have these turbo ventilators in the skylight. And it creates stack effect, because this turbo ventilators sucks out the air, and the air is forced in from the windows. So it really works very well for government, public buildings rather. And this is how you can see that the arrows can tell you how it works. And to the corridor side, where there's a courtyard outside, we have ventilators. Again, it gives you privacy, because it is about, especially, these IT buildings, they visualize all glass buildings. They think without using glass buildings cannot look modern. But I'm sure that this kind of structures look quite modern, and to really courtyard, this kind of courtyards really work very well in a public building or office building. Where you see there is a turbo ventilator on top, which creates stack effect. It sucks the air, or hot air goes up and it sucks it out, and as it throws it out, the air is sucked in from the windows. So that stack effect is not a new concept, but if you apply it properly, it gives you a very good natural ventilation system. So if you see in this image how it is shown, like the window to your right where the air is pulled in, and it is pulled into the courtyard to the left side window, where the left side windows are having the corridor to that side. So the windows are at higher level to actually have the privacy from the corridor. So this really works very well. And in this building, when people look at the building from outside, they see the face and they think that it might be disturbing the view from inside. But if you see this image down there of the cabin, it doesn't obstruct the view at all. It gives you a very good view. At the same time, it serves the purpose of reducing the heat and getting more natural air. So, and I already talked about these courtyards also help you to have additional waiting spaces. So now coming back again to the building envelope. This building envelope is also very simple. We haven't done anything innovative, new, but it's innovative. We have used the same fins which have been used in many old buildings, but the way they have been used, it looks different. And these fins again serve very well to the west side, as the vertical sun and west sun is inclined. So normally when people think about modern buildings, especially in IT sector, people think that it has to be a glass building, but that is not suitable for climate. But we can still use our own ethos in architecture, like fins or jalis in a very modern style, and building can look absolutely modern. If we see these images, you will find that this building looks very modern, irrespective of without using glass as the main facade element. And this is what is required in our climate. So what I always say is, like, it's a contemporary vernacular architecture, which we call as, because we have to use our vernacular ethos in a very contemporary style, which can give us our own style of architecture, which could be very modern. So thank you.
Thank you for taking us through a very insightful presentation, architect Sunil. It was very interesting to understand the various design considerations that you take for materials and daylighting systems. So before we close, I have a couple of questions for you. Is retrofitting an option to make buildings more energy efficient? Is there an example of a project where you had to retrofit to bring in more daylight, or maybe modify the materials to make it more energy efficient than before?
Yeah. We can. So yeah, we can of course do a lot of things. First thing is that we can modify the building envelope such a way that it allows us good light and ventilation. We can add some skylights to the building. It may not be a large skylight, but sometimes even a small slit in the ceiling can help a lot get natural light. We can induce some ventilation system, natural ventilation, which will allow us to have natural ventilation.
Right. So do you think green ratings are the motive for builders or designers to adopt these conventions, these energy efficient methods in construction, or do you think it's something that is inbuilt and something that everyone has to follow on their own?
See, basically, everyone must, now is high time that we all have to think about sustainability in architecture and green buildings. This green rating system somehow, the problem with rating system is that a lot of points are given to the other things than actual planning, architectural designing. For architectural designing, there are hardly any points, but there are a lot of points which are most of the times not in our control as a designer, like non-smoking sites. So somebody smokes on the side as a worker, it cuts our points. A lot of such things are there, which may be good, but I think a lot of focus has to be given to the basic principles of architecture, where one can achieve a lot of sustainability while in the design stage itself. So that part of the rating system has to be improved. And thing is that I think they should make it mandatory now, because unless it is mandatory, people don't go for it. So we have to get people used to think green way. Like we did these government buildings green because we wanted to, it was just initiative to start green movement in government sector.
All right, great. I'd like to thank you again on behalf of all of us at Classic Ed for sharing your thoughts with us today. There might be other questions that come in from the audience, and I'll make sure that I ask them to you and get your responses when you broadcast.
Hope it was good. There were a lot of cuts in between. Hope you edited well.
That's all right.
Thank you.
Thank you.